Okay, so now that we know about the monomers that make up a lipid, which is a macromolecule and can also be considered a polymer, let's talk about what the differences were between this lipid and that lipid. We know that these are the fatty acid tails, and within these fatty acid tails, this is where we see the glaring difference between this lipid over here on the left and this lipid on the right. So if the fatty acid tail has at least one carbon-carbon double bond, which is what we see here and was spoken about in the last screencast, it is said to be an unsaturated fat. That's right, folks. Unsaturated fats and saturated fats are different because of this carbon-carbon double bond present in one of the fatty acid tails. If a fatty acid tail has no carbon-carbon double bond, then, spoiler alert, it is considered to be a saturated fat. Now, which of these drawings is a saturated fat and which is an unsaturated fat? Exactly. This is your saturated fat, no carbon-carbon double bond, and you can tell that because there's no kinked tail, there's no curved tail. And over here, this is an unsaturated fat because we have our carbon-carbon double bond and we have our curved tail. Now, in this image in particular, this is an unsaturated fat. But this is to show you that not always in the images will they show you a kink in the tail or a curve in the fatty acid tails to tell you that it's an unsaturated fat. Sometimes you have to look very closely, like right here and right here we see carbon-carbon double bonds, right here and here. But if I'm ever going to test you on saturated versus unsaturated, I'll make sure that I use an image that shows you the actual curvature of a fatty acid tail to tell you which type of lipid you're looking at. So, is this saturated or unsaturated fat? Spoiler alert again, I already told you here's one carbon-carbon double bond, here's another, here's some right here. So this is going to be an unsaturated fat. And unsaturated fats tend to be solids at room temperature. And some examples are shortening, butter, lard. These are all solids at room temperature. Unsaturated fats, like we see pictured here with those carbon-carbon double bonds, those kinked tails, those actually tend to be liquid at room temperature. And some examples of those are like olive oil, vegetable oil, cooking oils in general. Oh, I'd like to go back, please. If I can. There we go. Excuse me. Saturated fats are worse for your health than unsaturated fats. And we don't have the time to go into all of that, but you need to understand that saturated fats are more harmful than unsaturated fats. Alright, so what the heck are lipids used for? What's the functionality of this macromolecule? They're used to store energy. This is why a bear in the woods will eat a whole bunch of food during the summer and fall and put on a lot of weight for the winter, because that's going to be all that extra fat or lipid content is stored energy for the organism. They're a primary component of the cell membrane for both you, me, and plants. And they have a really cool ability to not interact with water, so they can actually form like this natural waterproof coating that covers over a bird's feathers, fruits, the leaves of a tree, and has just a world of universal natural applications in nature. And a last one, and one I'm kind of fond of, I think this is very cool. No matter how thin or heavy you are, there are lipids coating your internal organs, and it's meant to insulate them from internal or external forces that could damage them physically.